Well, okay. So I know that kids seem to struggle the most with this idea of angle addition. Like what is it you're measuring when you're dealing with an angle? How do you mark the angle measurement? All of that is pretty confusing. So I thought this would be a really good follow-up to our lesson on angles, where we introduced angles and we introduced how you measure them and what's going on. So why don't we do this? Why don't we start with segments? And I want you to see how closely related the idea of segment addition is to angle addition. The only difference is segments are linear. They're one-dimensional. They just have length. Angles are two-dimensional. They have a length and a width. They have a rotation that we're measuring. So why don't you take a second, draw this picture, label the picture, and see if you can find both the numerical value of x and the length of segment BC. Welcome back. So I hope you actually did. I hope you took the time. You sketched this picture. You labeled segment AB to be 6x minus 6, segment BC to be 2x minus 1, and then the whole thing from A to C, I hope that you labeled as 5x plus 2. I happen to be a huge fan of using colors. I think that colors really bring out relationships. They really help you see that, yes, this red plus this blue should give you the purple. So 6x minus 6 plus 2x minus 1 equals 5x plus 2. Now it becomes just like what you did last year in Algebra 1. You just have to solve the equation. Combine the like terms on the left side, leave the right side the same, get your x's together, get your constants together, and you get x equals 3. Once you have x equals 3, you can take this value, you can plug it back into your equation. So now that we know x is 3, segment AC becomes 5 times 3 plus 2, which is 17. Segment AB becomes 6 times 3, remember x is 3, minus 6, which is 18, 12. And finally, segment BC becomes 2 times 3 minus 1, which is 5. Now, I know they just asked for the length of segment BC. It's 5. That's our answer. But I always think it's a good idea to take your x and to plug it into each of these values because you can do a real quick check. Is 5 plus 12 17? Yeah. And a real quick check tells you you did it correctly. Now, let's try one with angles. So again, why don't you take a second, why don't you pause the video, draw this picture, label the picture, and see if you can set up an equation. Okay, welcome back. So we have here the measure of angle MHA. So angle MHA is this angle right here. If I wanted to, I could go in and I could grab my highlighter. So I could get my pen and I could come in here and say, okay, this angle right here. And remember what an angle is. An angle is measuring the rotation. How many degrees does it take to rotate this ray HM, all the way over until it lands on ray HA? And that angle, that red angle, is 5x plus 10 degrees. You know, whatever x is, you put it in there, and that's how many degrees you have to rotate. And remember, we have arbitrarily assigned a full circle, a full circular rotation to be 360 degrees. Similarly, I can say that rotating ray HA, rotating it down here so it lands on ray HT, that is angle AHT. It is this blue rotation right here. And I know that that blue rotation is 3x minus 1 degrees. Now, by the way, here's a little side note. You'll notice that when I labeled angle MHA as 5x plus 10, I gave it one arc. And when I labeled angle AHT as 3x minus 1, I gave it 2 arcs. Usually, angles that have the same number of arcs are equal. And so I don't want to imply that these are equal angles. I don't want to imply that ray HA cuts the big angle in half. I don't know that. But what I do know is that the big angle here, where is it? This big giant angle, there it was, I lost it, is 9x minus 3 degrees. And so you can see that the red angle, which takes this ray, HM, to ray HA, it's this 5x plus 10 degrees, and this blue angle, which takes HA and rotates it all the way to HT, is the entire purple angle. That is the angle addition postulate. The little parts, red and blue, make up the big part, the purple 9x minus 3. And so if we set that equation up, we can solve it by getting your like terms together on the left side, keeping the right side the same, moving your x's, moving your constants, and we get x is 12. So that's a little review of the angle addition and the segment addition postulate. We will keep practicing that over the next couple days, and hopefully it'll start to sink in and it'll make sense. But please, if you're struggling with this idea, ask me and I'll give you some one-on-one help.